video, I'm answering the question which is coming from complex numbers. So the question is saying, given that z1 is equal to root of 3 plus I, and z2 is equal to 1 minus I root of 3, then it is saying express z1 and z2 in the polar form. So when you have been taught to express z1 and z2 in polar form, the first thing is very important to write the polar form. So polar form are in the form of z being equal to r cos theta plus I sin theta. So it's very important to remember this formula or the format of the polar form. So now our job here is to find r and theta. That's all. Then express them in this form. So let me start with z1. So for z1, I'm going to find r, which is going to be r1, and also theta, which is going to be the angle. So r is equal to root of x squared plus y squared, where x is going to represent the real part and y is going to represent the imaginary part. For z1, we know that z1 is equal to root of 3 plus I. So meaning the coefficient that we have here is just 1. So I'm going to say r is going to be equal to root of x root of 3 squared plus 1 squared. What is root of 3 squared? We are going to get 3. Then 1 squared, we are going to get 1. So 3 plus 1, we are going to get 4. And what is the square root of 4? It's going to be 2. Of course, we know that the square root can be both negative and positive. But for complex numbers, take it as positive always. So meaning we know that our r here is what? 2. Now it's very important for you to know the theta. Before even determining the theta, it's very important for you to plot a complex number. So we have z1 being equal to root of 3 plus I. So to plot this one, we are going to use the Cartesian plane. So for Cartesian plane, the x-axis represents the real part and the y-axis represents the imaginary part. This one is the real part and this one is the imaginary part. And the coefficient that we have here is 1. So you can just imagine that 1 is somewhere here. And here we can imagine that root of 3 is somewhere here. So we can just say we are going to have something like this one. Then here we draw a triangle and a theta is formed at this point. So here we have 1, then here we have what? 3. According to what we have here, this one is in the first quadrant, and in the first quadrant all ratios are positive. In the second quadrant sine is positive, in the third quadrant tan is positive, and in the fourth quadrant cos is positive. So now when you're finding the theta, always need to use this formula. Theta is equal to the inverse tan or tan inverse y divided by x, where y is going to represent the imaginary part and x is going to represent the real part. So from this triangle here, we can see that this one is the opposite and the adjacent is this one, hypotenuse to this one here. Here we can say theta is going to be equal to tan inverse. Our opposite here is 1. Then our adjacent here is a root of 3. Now using the idea of special angles, let me just draw the triangle. Here we have root of 3, here we have 2, and here we have 1. So now, remember here we have theta being equal to tan inverse 1 divided by root of 3. Now, which angle here is giving us this ratio here? Which angle is giving us this ratio here? The angle which is giving us the ratio of 1 divided by root of 3 is 30. Where is this 30 coming from? If we say this one is going to be the opposite, meaning this one is going to be the adjacent and this one is going to be the hypotenuse. Therefore, what we are going to have for tan 30, it is going to be 1 divided by root of 3. Meaning in the place of this one here, we are going to say it is what? 30. So meaning the theta that we have here is what? It is 30. Since our theta here is 30 degrees, and also r is 2, And remember the polar form here, it is z being equal to r, open bracket, cos theta plus I, which is the imaginary part, sine theta. So meaning our theta here is what? 30. Now sometimes you are going to find that this angle here can be expressed in radians. Now by expressing this angle in radians, just multiply the same angle by pi divided by 180. So we are going to say, let me just do it here, multiply by pi divided by 180. So here we can just say 0 and 0, they are going to cancel each other. That we have here is just going to be pi divided by what? 60. That is the theta that we are going to use here. So r we have, which is 2. The theta we have, which is pi divided by 6. Even here we have the same angle, which is pi divided by 6. So that is how you are supposed to express this answer in polar form. Let's try to look at z2. So as for z2, it is 1 minus I root of 3. So for this one, the first thing we are going to find r, which is r2. So here we are going to say the real part is 1, so 1 squared. The imaginary part is the negative root of 3, then it's squared. So we are going to say r2 is going to be equal to root of, so 1 squared we are going to get 1 plus negative root of 3 squared we are going to get 3. When we add we are going to get 4, and the square root of 4 is what? 2. So always you need to take the square root as a positive answer. So even here we have r, which is r2, being equal to 2. The next step we are going to find the theta. Remember, when finding the theta, you're supposed to use this formula, which is theta is equal to tan inverse being equal to, let me say tan inverse y divided by x, where y is representing the imaginary part and x is representing the real part. So let me try to draw what we have here. Okay, let me just erase this part and then draw it somewhere here. So this one is the real part and this one is the imaginary part. So remember we have z2 being equal to 1 minus I, which is the imaginary part, root of 3. So this one is the imaginary part, this one is the real part. So for the real part is positive. So you can just say 1 is somewhere here. So I'm going to put 1 here. And this one is negative. So you can just say it is somewhere here. So the point is going to be somewhere here. Now, let me just include it here. Then here we have 1. Then we are finding this theta here. So now, by using the quadrants idea, we can see that in the first quadrant all are positive. In the second quadrant, sine is positive. In the third quadrant, tan is positive. And in the fourth quadrant, cos is what? Positive. Meaning when expressing our answer in polar form, the only answer which is going to be positive here is for the cos. But as for the sine, it is going to be what? Negative. Why is it going to be negative? Because we know that sine in the fourth quadrant is what? Negative. That one is very, very important. So let's do this. Let's find our theta. So theta is going to be equal to tan inverse. So what is the opposite of this angle? The opposite of this angle is negative root of 3. So I'm going to use the modulus. So whenever you are having a negative somewhere there, you're supposed to use the modulus to eliminate a negative. So negative root of 3 divided by the adjacent. Our adjacent here is what? It is 1. Hypotenuse, we have already found hypotenuse, which is what? 2. So here you can just say 1 into root of 3 is just what? Root of 3. This negative is going to be eliminated because we have introduced the moduluses. So the modulus eliminates a negative. So theta is going to be equal to tan inverse. Then inside here we are going to have positive root of 3. Now, what is tan inverse? Root of 3. Similarly, here we are going to use the idea of special angles. So here we have 60. Here we have 30. Here we have root of 3. Here 1 and then here 2. So which angle here is giving us root of 3? Just root of 3 or root of 3 divided by 1. It is 60. Since 60, the opposite of 60 degrees here is what? it is this root of 3, and the adjacent is what? It is 1. So what I'm saying here is like this. Tan 60, what is the ratio? Because we know that tan theta is equal to opposite divided by the adjacent. So the opposite here is the root of 3 divided by the adjacent, which is what? Which is 1. So this one is same to what we have found previously. So meaning, in the place of theta, tan inverse, root of 3, we are going to put what? 60. So our theta here is going to be what? 60. Now, if you see properly here, the angle was formed in the fourth quadrant. Now, always, what you need to know here is that the angle always is formed starting from the positive x-axis. That is very, very important to remember. So the angle starts from the positive x-axis, going anti-clockwise. Now, here we are having 60. This 60 is the reference angle. It is the reference angle. So for you to find the actual angle, what are you supposed to do? You know that a circle always adds up to 360. So for us to find the actual angle, starting from this point up to this point, we are just going to say 360 minus 60. Then the answer is going to be what? 300. So the actual angle here is what? 300. But when the angle is formed in the first quadrant, that same reference angle is going to be equal to the what? The actual angle, because the angle is formed now starting from the positive x-axis. That is very, very important. Now remember, once you find the angle in degrees, you need to convert it into radians. So we are multiplying this one by pi divided by 180. So we can see that 6 into 30, we are going to get 5 pi. Then 6 into 18, we are going to get 3. So this is our angle that we are going to use. Now remember, for sine, is supposed to include a negative, because in the fourth quadrant, sine is negative. Okay. So let's now express Z2 in polar form. So our R was 2. For cos, it is going to be positive, because cos is positive in the fourth quadrant. So it's 5 pi divided by 3. Then here we are going to put a minus. Imaginary part, sine 5 pi divided by 3. So this one is our answer. So this one is very, very important to remember. So before you even find the theta, it's very important to sketch the graph so that you know where the angle is formed. And once you find the angle, you need to identify if it is the reference angle or the actual angle. In the previous question, we are expressing the question in polar form. Now for this one, it is asking us to express the answer in rectangular form. So it is saying, given that z is equal to root of 2 cos pi plus the imaginary part sine pi. So now, this angle here is in radians. So we are supposed to express it now in degrees. How do you express it in degrees? We know that when you have been given the angle in degrees, you are multiplying it by what? Pi divided by 180. Now this one is going to be now the display of conversion. So instead of us multiplying it by pi divided by 180, we are going to say is pi multiplied by 180 divided by what? Pi. So pi and pi, they are going to cancel each other, meaning the angle here is equal to what? 180. Okay. That is the actual angle now in degrees. So now, what we are going to do here, let me draw the Cartesian plane. So here we are going to have 0 degrees. Here we are going to have 90, 180, 270, 360. So let's try to convert these angles into radians. So 0 degrees is just going to be 0 degrees in radians. So it is 0 radian. What about 90? So for this one, we are going to multiply it by pi divided by 180. So therefore, we are going to find that the answer here is just going to be pi divided by what? 2. So 90 degrees in radians, it is pi divided by 2. So whenever you see pi divided by 2, that one represents what? 90 degrees. So let's come to this one. So for this one, I'm going to multiply this 180 by pi divided by 180. Therefore, the answer is just going to be pi. So whenever you see pi, that one represents what? 180 in radians. let's come to 270. So as for 270, it is going to be, so here we are going to say 9 into 27, we are going to get 3. Then 9 into 18, we are going to get 2. So it is 3 pi divided by 2. That is in radians, 270. Let's come to 360. So for 360, multiply by pi divided by 180. So 180 into 360, we are going to get what? 2. So it is 2 pi. So whenever you see 2 pi, this 2 pi represents 360 now in radians. We have already changed now the angle from radians into degrees. So the polar form of this one is going to be root of 2 cos 180 plus the imaginary part sine 180. Okay, so using the same Cartesian plane, this one is the real part and this one is the imaginary part. One thing that you need to understand here is that when it comes to these ratios, cos and sine, you're going to find that sine in the real part is always 0. Then when it comes to cos, cos is always 0 in the imaginary part. That is very, very important to remember. So we have 180 here. 180 is formed from where? Since we know that from this point up to this point, this one is what? 90. Even from this point up to this point, this one is what? 90. When we add, we are going to get what? 180. Now, this one is the positive side and this one is the negative side. So cos 180, it is going to give us what? Negative 1. Where is negative 1 coming from? Because the angle is formed on the negative part of the real part. That's very, very important. So in the place of cos 180, we are going to put negative 1. Now what about sine 180? Since sine in the real part is 0, it's going to be 0. Now what about this one? Suppose the angle is 270. So if the angle is 270, meaning we are going to consider now the what? The imaginary part. So on the imaginary part, for cos, it is going to be 0. But for sine, it is going to be what? 1. Now since it is formed on the negative side here, it is going to be equal to what? Negative 1. That one is very, very important. So in the place of this 180 for cos, we are going to put negative 1. Then for this one, we are going to put 0. So we have z being equal to root of 2, open bracket negative 1 plus 0 and the imaginary part. Multiplying these numbers, we are going to get negative root of 2 plus 0i. So this is the format of the rectangular, or we have expressed our answer in rectangular form. So that is how you are supposed to answer this question. Thanks for watching.